Okay, now let's look at an example where you wouldn't be able to rewrite it like that, and you have to use the chain rule. So for this example, if y equals the square root of 3x squared minus x plus 1, we want to find y prime. Okay, so in this example, we definitely cannot rewrite this. We have a function inside a square root. So again, one of the keys is making sure you do have a composite function. Because if you have a composite function, you have to use the chain rule. And in this case, we do have a composite function. We have this polynomial, 3x squared minus x plus 1, inside a square root function. All right, so let's do this using u substitution again. And so when you use u substitution, the first thing you have to do is determine what is u. Okay. And u is the inside part. 3x squared minus x plus 1. Now if u is this whole thing, that means y is going to be the square root of u. Okay, so let's go ahead and get du dx. So du dx is, let's see, derivative of 3x squared is 6x. The derivative of a negative x is a minus 1. And the derivative of 1 is 0. Okay, now we need the derivative of this. And in this case, rewriting is a good idea. So we're going to say that y equals u to the 1/2 power. So that means y prime, or not y prime, dy du. So dy over du, let me get rid of that, is 1/2 times u, and then we subtract 1 to the negative 1/2. So we can still use the power rule. So it becomes 1/2 u to the negative 1/2. So dy du, let me write it down here, dy du equals 1 over 2 times the square root of u. Just to make sure we're clear on that. So now we can go back to this. So remember, use substitution, it's dy dx equals dy du times du dx. So we end up with dy dx equals dy du times du dx. So let's see here. Dy du is 1 over 2 times the square root of u. Du dx is 6x minus 1. Now we don't want to have a u in our answer, so we're going to have to use back substitution. And so we end up getting dy dx equals 6x minus 1 all over 2 times the square root of 3x squared minus x plus 1. And this is our final derivative. Okay, so now that we have that, let's see if we can find the derivative of this composite function by using the inside-outside rule. Alright, so let's say, well, first let's write it out. You have the inside-outside rule. Okay, so now even though this looks a lot different than what we have up here. I mean, they are the same because it is the same rule. And the essence of the inside-outside rule is we're going to do U substitution in your head. So U substitution in your head. So in essence, we're trying to just get rid of all of this work and try to go straight to the derivative in a couple of steps. But the inside-outside rule states we're going to take the derivative of the outside. So we take the derivative of the outside, then multiply by the derivative of the inside. So that's kind of how we keep this straight. And that's what this means. If you have a composite function, you take the derivative of the outside function and then multiply it by the derivative of the inside function. So let's look at this example up here again. If y equals the square root of 3x squared minus x plus 1, find y prime. So this is the exact same one that we just did up here, but instead of doing all this work, we're going to try our inside-outside rule. And so I first do like to rewrite. I'm going to rewrite this so we have to the 1/2 power. So we have y equals 3x squared minus x plus 1 to the 1/2. Now because we're going to do U substitution in our head instead of going through all this work, you do have to decide, well, what was the inside part and what's the outside part? The inside part is this 3x squared minus x plus 1. That's what we set equal to U. The outside part is all this to the 1/2 power. So that's what we will let y equal, the square root or U to the 1/2. So we're just keeping track of these two things, but just down here without writing it out. So y prime is going to be the derivative of the outside. So we know that the outside is this stuff to the 1/2 power. So this function to the 1/2 power. So you got to kind of in your brain think, well, let me take the derivative of that. So I bring out the 1/2. So I have 1/2 times, and then rewrite whatever's inside again, 3x squared minus x plus 1. And then I go ahead and do my minus 1 up here. So it's a negative 1/2. Notice that matches what we did up here, 1/2 u to the negative 1/2. Then we're going to multiply that by the derivative of what is inside. So in this case, it is, well, the derivative of 3x squared is 6x minus 1. And that's what we did right here. So we took the derivative of the outside, brought out the 1/2, rewrote the inside again, just as it was, the negative 1/2. Then we took the derivative of the inside. And so we end up with y prime is going to be 6x minus 1 all over 2. You know, you got the negative 1/2, so that's just the square root in the denominator. 3x squared minus x plus 1. And we were able to find the exact same derivative. So even though back when I first wrote down the chain rule, I said, oh, there's two ways we're going to do this. There really is. There's only one way. It's just sometimes when you first start using or finding the derivative using the chain rule, sometimes U substitution is just easier to kind of figure out. But I would say over time, you need to be able to do this, the inside-outside rule, because you do want to be able to find the derivative quicker than going through this whole process. But if at first you need to use that, that's fine. Just to get understanding. All right, let's do one more derivative in this video and see if we can use the inside-outside rule without using u substitution first. So let's say we have y equals the sine of 2x cubed. Okay, so we want to find y prime. Alright, so here we have the sine of 2x cubed, and the first thing we have to do is, well, we have to recognize it's a composite function, which it is. We have this function 2x cubed inside the sine function. Then we have to determine which part is the inside, which we kind of already did. This is the inside part, and then the outside part is actually the sine. So let's take the derivative of this. Y prime. So we take the derivative of the outside. So the derivative of the sine is the cosine. And when you take the derivative of the outside, it doesn't matter what's inside the function, just rewrite it again. 2x cubed. Then, once we take the derivative of the outside, we take the derivative of the inside, which is 6x squared. So we end up with y prime equals 6x squared times the cosine of 2x cubed. And that would be our final derivative. So we could have done this using u substitution, but I think most people agree that once you learn how to do this without going through the steps of u substitution, it's so much quicker, and I would say that after this section we pretty much never use substitution. But if you need to practice with u substitution for a little while to kind of get used to what is inside, what's outside, please do, because in a couple months when we come up to a composite function, we can't spend too much time figuring out what the derivative of this is, and you do have to understand how to take the derivative of this.